build them from word form. So let's say calcium hydroxide plus lithium phosphate. And then it yields, so we'll put the arrow there. Our products would be lithium hydroxide and calcium phosphate. Okay, do we see what happened here in terms of our products and our reactants? Yeah, they just switch places. And so that's a type of reaction that we're going to look at today called a double displacement reaction. But what happens is our cations and our anions just flip-flop partners, basically. Okay, so between our products and our reactants, that's what happened. But your goal right now is to take each of those from word form to chemical formula, and then you're going to balance the reaction. Okay, so that's going to be your goal for the next couple minutes. If you want me to check your compounds before you start balancing, raise your hand and I can do that. Make sure after you have your equation built, you do go ahead and balance it. Okay, those should have been our chemical formulas, so hopefully we had that. In this case, it was easier to balance via polyatomic ions, right? I saw that on this side I have 2 phosphates, right? On the right side I had 2 phosphates, so I needed 2 phosphates on this side, right? I kept phosphate as a whole. Here I had 2 hydroxides, right? So I had to get things lined up rather than splitting up into oxygens and hydrogens. You still can do individual elements. That's fine. But if you can see that, okay, on this side I have 2 phosphates, so I need 2 here, right? Which would make 6 lithiums, which means that goes here, right? And so I can kind of work from that. Always, 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 it will work to go element by element. So if that's the system that you're comfortable with, by all means use that, right? But as you get more comfortable with balancing, you might start to pick up things like balancing by polyatomic ions as a whole. Okay, does that kind of make sense? Questions here. Building your formulas still might be the most difficult part, right?
I'm confused, like where to start.
Section of notes today is going to be about types of chemical reactions and types of chemical equations. Okay, so the first type of reaction we're going to talk about, we're going to look at 4 specific types of reactions, the first of which is called a combustion reaction. Okay, in a combustion reaction, we always have a combination of oxygen gas, okay, right? O2 is one of our special molecules. Does anyone remember the name of that molecule that has to be in a pair? A diatomic. Good. A diatomic has to exist in a pair, and oxygen is one of them. So oxygen gas combines with what we call a hydrocarbon. Okay, a hydrocarbon is any combination of carbon and hydrogen atoms, right? C to the X and H to the Y, right? It could also have an oxygen on there too, but hydrocarbons in general start with C something, H something. Okay, so that's a hydrocarbon. any combination of hydrocarbon plus oxygen should yield the products carbon dioxide and water. So carbon dioxide and water will always be the products of a combustion reaction. So that's a really good clue for us if we're looking at types of reactions. Synthesis reaction, what's it mean to synthesize something? What's it mean to synthesize something? Anybody know? Or what does synthetic mean? Yeah, fake, kind of, right? Or man-made, right? So to synthesize something means to kind of make it from scratch. Okay, so this happens when two or more compounds combine to form a complex molecule. Okay, two or more substances combine to form a complex molecule. So complex molecule, we just means, has a cation and has an anion, basically. Okay, or has two parts to it. So a synthesis reaction, the most generic form of a synthesis reaction, or the basic form of a synthesis reaction, is A plus B yields a combination of AB. Right? A being the cation, B being the anion. Okay, so you need to know kind of the basic reaction for each of these four types. So the basic or the most bare bones chemical reaction for combustion would be CXHY plus O2 yields CO2 and H2O, right? That's the bare bones reaction for a combustion reaction. Because it has specific molecules or specific atoms that it has to deal with. The other types of reactions can deal with any type of element, right? Any atom, any element can be part of the other reactions, which is why we use just A, B letters for those. Okay?
So should we write that?
This one right here. Yeah, I wouldn't bother writing the sample one.
So
I would maybe have that one. Yeah. Yep. Or you can just erase the sample down so that you don't have the subscripts and stuff for the coefficients. A synthesis reaction is when iron and sulfur combine to form iron sulfide, right? That's it. Anytime we see two things combining to form one bigger atom, that's a synthesis reaction. Okay, the second type is the opposite of a synthesis, called a decomposition reaction. So what happens in decomposition? If something decomposes, what happens? Yeah, it breaks down, right? So that's what happens. A complex molecule is breaking down into one or more simple compounds. Okay, or simpler compounds, we could say. So it's just a kind of a reverse reaction of a synthesis. It's when we start as a complex molecule, AB, and we break it down into A plus B. Okay, so an example of that is when we break down water into form hydrogen gas and oxygen gas.
So write down the first one.
Yeah, the first one. Yeah, you don't have to have the examples. As long as you could look at this and identify that it's a decomposition reaction, right? That's what the goal is here. You're going to have to balance reactions and identify what type of reaction is it. Okay, so is it synthesis, is it decomposition, is it combustion, or is it one of the last types? Okay, synthesis and decomposition reactions are opposite of one another. Okay, so one builds it up, the other breaks it down. Okay, the last type we're looking at is called a displacement reaction, and really there's two types of it, so I kind of told a lie when I said there was four. Really there's 5 total types, right? The next type is called a displacement reaction. And so a single displacement reaction means one element trades places with another element between the products and the reactant side. So one of our objects trades places with another. So it could be the cation or the anion that switches places. But essentially what it looks like, its basic formula is A plus BC yields AC and B. Okay, in any chemical formula in which we have 2 parts, right, we have to have a cation and an anion. So that means that B has to be a cation and C has to be an anion. So in order for them to combine, that means A has to be a cation and C would combine to form our new compound leaving B to be an anion on its own. Okay, we'll always see a combination come together between cations and anions. So this single displacement reaction, right? A and B just traded places. Okay, so an example of that would look like this, right? Which is a little more intense for us to look at. But single displacements are a tiny bit harder to identify. But essentially, we had magnesium and hydrogen switching place, right? Even though there's still hydrogen in this hydroxide atom, essentially what we had them do is switch places. Okay. Single displacements are a little bit harder to identify. It's one of the least common types of reactions that we'll look at. The next one is the most common and will be the easiest to identify. Okay, called a double displacement. So double displacement happens when the anions and the cations completely switch places. So we looked at that in our first example today, when our cations and our anions completely switch places. Okay, so in a double displacement reaction, when it's listed like this, right, our cation always comes first, our anion always comes second. So if you can do this double kind of arrow system, it will always build your new products for you, right? The cation from the first, which is A, will combine with the anion from the second, which is D, right? So it will form AD. The cation from the second will form with the anion from the first. Which, why don't we list it BC over on this side? Why would we not list it as BC here? The cation has to come first. Okay, so when you put those back together, when we displace our compounds, we put them back together, it has to be cation and anion. So since we know C is the cation and B is the anion, it has to go in that order when we write our chemical formulas. Okay, those are the easiest to identify, and that's what we will use the most often is double displacement reactions. Okay, so there might be times where I tell you, these are our two reactants, they combine in a double displacement reaction. You have to now predict the products and then balance the equation. Okay, so we'll get to that part of it too. Okay, any questions about those types of reactions? Okay.